My name is Driton and I will present our work conducted at the Technical University of Munich under the 6G Live project named SGPCR Spherical Gaussian point cloud representation with its application to object registration and retrieval. We present our 3D point cloud representation to improve view retrieval and alignment of uniformly sampled CAD models from a public database to detected and cropped models from a 3D point cloud. Due to no point-to-point correspondences between scanned real-world point cloud and uniformly sampled CAD models, a need to finding a generalized representation of point clouds arises. By finding a generalized representation, our model is able to find rotation, translation, and scaling information between two point clouds without point-to-point correspondences, solely from the structural information. For our representation, we exploit the rotation-equivariant spherical Gaussian mixture models. To generate spherical Gaussian mixtures, we first create a surface-sampled sphere, resulting in one parameter v. We use this sphere to sample points p, which number corresponds to the number of spherical Gaussians used. We use this to generate features a. Due to the inherent definition of spherical Gaussians, this representation is rotation-equivariant, as seen from the following equation, showing the cos rotation can be cancelled by finding the inverse rotation. Further, to improve the representation, we introduce a rotation-invariant convolution, which we term spherical Gaussian convolution or SGConv. Finally, we use singular value decomposition to generate rotation and translation information. We then use this to create a prior, rotated and translated bounding box, from which we obtain a first prediction of the final scaling information. To train SGConv and the spherical Gaussian representation, we introduce the spherical Gaussian loss, which consists of a distance metric, L1 translation loss, L1 scaling loss, the mean isotropic error, and the orthogonality loss for rotation. We show the evaluation of different number of spherical Gaussian mixtures on the ModelNet 40 dataset with no point-to-point correspondences. We show that even with a low number of spherical Gaussians and parameters, reasonable results can be attained. Our model significantly outperforms similar models on the ModelNet 40 dataset with no point-to-point correspondences. Here we give a qualitative evaluation of our approach. Further, our model outperforms cat-to-cat approaches by solely improving the alignment process. We conduct our experiments on cropped 3D point clouds attained from the initial 3D detection of a generic 3D detector. Further improvements are shown by our qualitative evaluation. To conclude, we introduce a novel rotation-equivariant representation of point clouds for spherical Gaussians. Further, we exploit the properties of rotation-invariant convolutions for efficient and precise registration. Lastly, we introduce a point cloud registration pipeline for 6 and 9 degrees of freedom on highly noisy point clouds with zero point-to-point correspondences.